In this video, we're going to learn about measures of central tendency. So before getting into the notes, I just want to summarize those three measurements that we are going to learn about in this video. They are the mean, often called average, or expected value, the median, and the mode. These three measurements tell us in some sense where the center or the middle of a collection of data is located. All right, so let's go ahead and get into the details. So first, we're going to look at a median. The median value of a set of data is the middle value. And this middle value, or median, divides the data into two equal halves. So let's look at this based on an example here with two cases. Because depending if our data has an odd number or an even number, will affect how we calculate or determine the median. So first of all, notice these two data sets are sorted. So that's kind of the first step that you need to do in order to find a median. Sort the data. And it's best to sort it from smallest to largest. Then the median, if we have all of our data, tells us where the middle of our data is. So we should have about 50% of our data on either side of that median. All right, so first up, the case where we have an odd number of data sets or the odd number of data values. So in this case, we have 1, 2, 3, 4, 5 data values. So if we count up to the third one, we will find the middle value or median. Now, the story is a little different in an even number of values. Notice here we have 1, 2, 3, 4, 5, 6 data values. So the median should occur in the middle, but there's no number here. So what we have to do is use the two numbers on either side of that middle and take an average of them. We're going to see what an average is in a little bit. But we can see here the calculation would be we add them up and then divide by 2. So for us, this is going to be 13.5. So our median here is 13.5. And just to be really explicit, I'll write out that the median in this first case is equal to 12. The median in the second case is equal to 13.5. And these are the only two types of cases that you'll see for how to compute the median. If our data has an odd number, then we just take that middle value. If we have an even number of values, then we need to take an average of the middle two values. Now let's consider the mean or average of a data set. So the mean is our next measure of central tendency. It's also known as the average of the data. And we calculate this by adding up all of the values and dividing by the number of values that we have. So here's some notation that I want to introduce. So if we're talking about a population mean, so we're able to collect data on everyone in the population, and we find that mean or average, we use this Greek letter mu to denote that average. If, however, we just have a subset of our data, so we've collected a sample or a subset of our population, we have a sample mean, and we write that with X and then a bar on top. So this first symbol is called, we pronounce mu. And the second symbol is called X bar. So that's just the language that we refer to it as. All right, and so here what I have is just notation, how we compute that sample mean. So this numerator, you don't have to worry about these symbols too much, but you might see this come up in your class or in research articles that you read. So this Greek letter sigma means we're going to add up all of the data values, all of the X's in our data set, and then divide by n the number of data values we have. So let me just notate this a little further. So in this formula here, let's define a few of the notations you're seeing. So n here is equal to the sample size. This Greek letter sigma is a summation. It means we add up all of the little x's. The little x's are the data values. So for example, if our x's, x1 say was 62, x2 was 65, x3 was 68, then we could write the sum of the x's as 62 plus 65 plus 68, which would be 195. You can check me on a calculator. But that is just some details about that notation. All right, so let's go ahead and let's do one more, average, or rather central tendency, and then let's look at an example of computing an average. So lastly, we're going to look at the mode. The mode is the most common data value in a data set. We calculate this by finding the data value that occurs the most number of times. So let's find the mode for one of our data sets in the above cases. So let's go ahead and compute an example. So let's consider the data set that we already saw in that second case. So we have, let's consider the data 3, 8, 12, 15, 18, and 18. So here is our set of data. Which number occurs most often? Well, we see that 3, 8, 12, and 15 occur once, 18 occurs twice. So in this case, 18 is our mode. All right, so now let's dive into the mean calculations a little bit by looking at two examples. All right, so we're just going to look at these two. It says 3, but that was just a typo. All right, so let's go ahead and start by looking at data set 1. So let's compute that sample average or sample mean. So to do that, we're going to add up all of the data values. So we'll look at 3 plus 8 plus 12 plus 15 plus 18 plus 20. And then we'll divide by the number of values we have, 1, 2, 3, 4, 5, 6. So divide by 6. So go ahead and pause the video and check your calculation, see about putting this into your own calculator. And what you should be getting is that this x bar is equal to 12.666, where that 6 repeats. So in other words, 12 and 2/3. So we can see that that 12 and 2/3 is going to land somewhere here, which looks like a pretty good job of showing us the center of that data. Now let's look at this data set B. So let's just take a moment before we compute that mean to reflect on how this B data set is different than our A data set. Well, you should notice that we have a 205 here. In the original data set, our largest number was 20. So we can kind of get a sense that this 205 is kind of an outlier, meaning it's a value that's very far from most of the other data values. So let's see how this outlier affects our mean. So we can compute x bar now as the sum of 3 plus 8 plus 12 plus 15 plus 18 plus 205. And again, we have 6 data values, so we're going to divide by 6. So now if we type that into our calculator, we should be getting something like 43.5. So notice now where that mean lies on our data set. It's somewhere somewhere up here. So we can observe that this outlier here had a pretty big effect on our mean. And we're going to see that in a little bit when we look at a distribution. But I'm going to go ahead and just make a note of that. I'm going to do a little star here. I'm going to say outliers have a big impact on the mean. So why does that matter? Well, if we are looking at a set of data and there are some outliers, it means that the mean or the average of the data set is not a very good measure of the center. All right, let's continue our notes. So now we're going to look at some different distributions and see how the mean, median, and mode relate to the shape of our data if we were to graph it. So let's go ahead and start with looking at the median. So I'll use M to denote that median. So when our distribution or the data looks fairly symmetric, bell-shaped here, then the median is right here in the middle. Now, if we have skewed left data, so meaning we have some outliers on the left, or skewed right, outliers on the right, then the median is still in some sense sort of that middle of the data, if we look on a distribution. So we still have equal parts of the data on either side, even though there's some that are smaller here and larger here, we still have equal amounts on either side. So that median takes place below that largest hump of the data. So our median is going to be about here. And in the last example here. But what is the effect that these distributions have on the mean? Well, when our data is symmetric, the mean is going to also land in that center. If we take an average of all of our data, we're also going to land in that middle. When our data is skewed left, so we have some left or low outliers, our mean's going to be pushed lower. Those smaller data are going to have an effect on this total average. And then similarly, though, in the other direction, when we have right skewed, and we have some large outliers, as we saw in the previous example, those large values are going to make our mean get larger. So we can make some conclusions about the mean and the median, the relationship between them based on the distribution. So in the case when we have a symmetric distribution, our mean is about equal to our median. In the case when we have our skewed left or low outliers, our mean is going to be larger than our median. Oops, sorry, I said that wrong. I'll write it correct. Our mean is going to be smaller than our median on the left. And in the case when we have large outliers, our mean is going to be larger than the median. So let's continue looking at distributions by looking at an actual distribution of box office earnings from Hollywood movies. So on this distribution here, what we have is a dot represents the earnings for one movie. Earnings from one Hollywood movie. So we've taken a whole collection of movies and we've plotted where they are based on their earnings. So then we might be curious about the average or mean earnings and the median. So I'd like you to take a moment and pause the video and think to yourself, where would you expect to see the median and where would you expect to see the mean? So let's start with the median. So in order to find the median data value, we need to find the middle dot here. So we could go through, cross off a small dot, a large dot. Keep going. You could also count how many dots we have and then just find the middle one. I encourage you to do that and pause the video if you would like. When you do that, you'll find that that median value or the middle dot will occur somewhere between these two bars. So our median is here. And recall, so rather here, if this is around 200, then our median is about at 50. And this is probably in thousands of dollars. But notice how there's a few movies. So if we're thinking about the mean earnings, there are a few movies that make a lot of money in the box office. These are those blockbuster hits. These are outliers of our data. And we can see that clearly. Most of our data is right here. So these out here, those are for sure outliers. So what those outliers are going to do is raise our average earnings. So we're going to be somewhere more like up here, somewhere more around 200. So if we are curious about where most of the movies or the amount that most movies earn, we wouldn't want to look at the mean. We'd instead want to look at the median. The median would be a more realistic measure. And a summary we can make, well, the median we say is resistant to outliers. So even with an outlier, it doesn't resist, or it does resist rather. It stays in its place, while the mean is not. So the mean is not resistant to outliers. It will be moved if there are some outliers. All right, so now let's just summarize this video. So there are two different sets of measures for central and spread. So we just looked at central measurements in this video. So to summarize, if our data is skewed, meaning we have outliers, or our data distribution looks like this, where we have a lot of outliers up here, or like this, where we have a lot of low outliers. Then for the measure of center, we're going to use the median. To measure the spread or how far apart our data is, we're going to use something called the IQR, which we'll see in another video. If, however, our data is symmetric, so no outliers, and in fact, our distribution looks rather symmetric or bell-shaped like this, then we're going to use the mean to measure the center. And for the spread, we'll use the standard deviation, which you might meet in another video. Awesome. Thank you for watching.